Hey everybody, this is section 5.6. The title is Graphs of Other Trig Functions. So in the first video in this lesson, I'm going to show you how to graph tangent and cotangent waves. And then in the second video, we're going to do the rest of the reciprocal trig functions, cosecant and secant. So let's start with tangent. And in order for you to be successful here, you do need to remember how we can find tangent. And one way to do that, it's not a label we use on our unit circle, but remember that you can take sine values and divide them by cosine values. So if you think about all our spots on the unit circle, I'm just going to highlight a few here. I'm going to do the corners and the in-betweens. Okay, so in my 0 or 2 pi radians, the sine value is 0 and the cosine value is +1. That means tangent is equal to 0. At pi over 4, we have root 2 over 2 for both of those. So you end up with the same thing over itself, and that means that tangent's going to be 1. At the top, or at pi over 2, the sine value is +1, but the cosine value is 0. Dividing by 0 means that that's going to be undefined. That's a location where tangent is undefined. Next, at my 3 pi over 4, we'll have root 2 over 2 again, but one of them is negative. That means that tangent is -1. Hopefully you're catching on what I'm doing here. We're going to have 0 tangent value at pi, +1, and -1. And then this at 3 pi over 2, I forgot my bottom corner here, that's going to be -1 over 0. So this is another place where tangent is undefined. So take a look at this and see how long it takes for something to return back to its original value. It takes pi radians for that to happen. Pi radians for us to get back to undefined. Pi radians to go from 1 to 1. That is the reason that the period of tangent is pi, and we've discussed that in a previous video. That's a non-transformed tangent. Okay, so I snuck some labels on our graph there. I'm going to do 2 wavelengths. I keep having to move this box so you guys can see. Okay, the expectations, I would like you to do two wavelengths when you're doing your graphs of cotangent and tangent. I'm going to start with my undefined values. So those are the corners, top corner and bottom corner. We are undefined at pi over 2, and that means there's an asymptote there. Also at 3 pi over 2. If I were to start at 0 and go clockwise, that would take me back to -pi over 2. So to complete my 2 wavelengths there, I'm going to use those spots for my asymptotes. So next I'll plot the curves. At 0, the tangent value is 0. Then at pi over 4, it's at 1, and it's only going to increase from there. At -pi over 4, it's at -1, and it's going to decrease from there. So I only have 3 dots, but you're just going to have to trust me that the tangent wave looks like this, okay? This is a non-transformed standard tangent wave. Starts high, goes low. From left to right, it's an increasing function. So now let's talk about cotangent. There's a lot of similarities. We should be able to go through this pretty quickly. Remember that cotangent is now the reciprocal of tangent, so that means it's cosine divided by sine. So we're going to have some similarities. We still have 1 and 1 and -1 and -1. That hasn't changed. But now we're going to have our 1 in the numerator and our 0 in the denominator at 0 or 2 pi, and that means we're undefined at 0. We're also going to be undefined at pi, and then we're going to have our zeros at pi over 2 and 3 pi over 2. All right, so I've got my labels on there. And we have asymptotes at 0 and at pi. I'm going to do 2 wavelengths, so I'm going to put another one at 2 pi. And again, that's for the non-transformed cotangent. At pi over 4, we're going to be up at 1, then we hit 0. At 3 pi over 4, we'll be at -1. So you'll notice cotangent starts high and goes low. It's a decreasing function from left to right in that little period. Okay, so those are the basics, and now I'm going to do some examples that have transformations. We'll do one of each. This darn box, never had so much trouble with it. Okay, there we go. So very similar. I'm not going to spend a lot of time talking about A, B, C, and D because that all correlates back to our sine and cosine stuff. The amplitude in this particular function correlates to the a value. It is 1, but I do want to say that amplitude, I'm not really going to be looking for that in terms of your graph. An amplitude change is going to be a vertical stretch. The only thing that's really going to change the general shape is if there were a negative in front of that, and remember that that's going to reflect that over the horizontal axis. I'll talk more about that when I get down to the bottom here. To calculate the period, this is different than we did in sine and cosine, and that's because the standard period of a tangent function is pi. So I need to do pi divided by b, not 2 pi divided by b. That's very important. So my b value in this example is +2, and that means that pi over 2 is the period. We do have a period change. It's squished. It's cut in half, okay? The phase shift is calculated the same way, c divided by b. C in this problem is pi over 2, and B we just found out that was 2, so that's going to equate to pi over 4. And let's see, it's a plus sign in there, so that means that we're going to go to the left. And lastly, the vertical shift correlates to the D. Any adding or subtracting, we are going up 1 unit. Just as I did with sine and cosine, I'm going to approach these two together for my first initial shape, and then I'll do any translating phase shift, vertical shift there at the end. So the period change is pi over 2, and a tangent function is going to straddle the the vertical axis until there's a shift right or left. So the period was pi in a standard function. It's getting a little bit squished, so it's actually pi over 2. Half of that is going to happen to the left of the origin, and half of that is going to happen to the right. So do you see that this is a total distance of pi over 2 units? That would be my original unshifted tangent. That's 1 wavelength, okay? So I had to do labels in increments of pi over 4. So let me do another one. 2 pi over 4 would be the same as pi over 2. And I'm going to do one more. That would be 3 pi over 4. I'm going to do some looking ahead. Eventually my phase shift is going to take this thing to the left, pi over 4 units. So I'm actually going to add one more label, one more increment of pi over 4, which would be negative pi over 2 to the left. Okay? All right, so tangent starts low and goes high. Between those asymptotes. My waves are not perfect. That's okay. I'm doing my best. Doing my best with this pen. Lastly, I'm going to do any translating. I'm going to take care of a phase shift, left pi over 4 units, and also up 1. That's really the only time I need you to put a label on your vertical axis. In fact, I'm going to do like a very light dotted line. And what I'm going to do is first move the asymptotes. Every asymptote needs to go pi over 4 units to the left. I'm doing those in red right now. So we're shifting everything over pi over 4 units to the left, and just for those 2 wavelengths. And then what I'm going to do, if you watch my cursor, I'm going to take the dot that was in the origin. That would move over pi over 4 units to the left, and it's also going to go up 1. So my final wavelength there is the red one. You can see it gets a little bit tricky to keep track of things. So the more things you can do in one step on your graph, the better. In fact, if you can do all of this at once, good for you. I do want to point out, a lot of times students will get negative tangent and cotangent confused. You need to be really careful because remember that those 2 graphs don't fully align. They're staggered a little bit in terms of where their asymptotes are. So even if I were to do negative tangent, that would take this graph and totally reflect it over the horizontal. It's still going to go through the origin though, so be careful. Just wanted to mention that. I'm going to do one more example here, and that's with a cotangent graph. The amplitude is 3. Again, that's not really something I need you to display on your graph unless, of course, the a value is negative and there is a flip. The period, the standard period of tangent or cotangent is pi. I need to do pi divided by b, and b in this problem is 1, so that means the period is pi. Awesome. I love when that happens. Next, we're going to do the phase shift. That's c divided by b, and our c value is pi over 4. We're dividing it by 1, so it is just going to be pi over 4. It says minus in that set of parentheses, so that means we're going to the right. And there is no vertical shift. Wonderful. All right, I'm going to get some labels on here. So you do kind of want to think ahead. The first thing that I started with was pi. Then I cut that in half, so I knew where to put my x-intercepts. I did that again for the second wavelength, 2 pi, cut that in half. The only reason I added the tick marks for the quarters is because of the phase shift. So I needed to add those marks so I know where to put things. Just like I did the last problem, I'm going to start with the period change first, which there isn't one, so it is standard cotangent. So that means an asymptote through the vertical axis and also through pi. For my second wavelength, before it's shifted, it would be at 2 pi. Right in between there, smack dab halfway, put your intercepts, cotangent, starts high, goes low. Okay, so my purple graph is my non-phase shifted graph. So what I'm going to do from there is take every single thing and move it pi over 4 units to the right. Here's my asymptote, there's my intercept, here's my asymptote. So I'm focusing my eyeballs on the red. Starts high, goes low. Okay, I'm going to do that for my second one. Here's my purple asymptote. That moved over. I took care of that already. Here's my intercept. I need to move that over pi over 4 units. I need to take my asymptote, also move that over pi over 4 units. Okay, there we go. There's your cotangent transformed graph. We're going to stop there, get you guys some practice on those, and then we'll move on to the rest of the reciprocal trig functions in the next video.